Alright, we are now looking at 1D.2. Our mastery learning objective is I can calculate missing dimensions of three-dimensional figures by identifying known values. So, before we really get into that, the first thing we're going to cover is Cavalier's principle. This is kind of more of what we did yesterday, but it's a good principle to know. And Cavalier's principle states, if two figures have the same height and equal cross sections, and they have the same value. Let's go with this. Two figures have the same height. I actually have three figures here. All three of these figures have the same height. I think we would agree with that. And they all have equal cross sections. So these red things here are cross sections. I basically cut the figure with like a string and see what happens. Okay, so like this was Kelly and I cut straight through it, it would make a square in there. It would make a square here, and it would make a square here. It doesn't matter that this is curving, right, that this is curving as we go around. This one area right here is a square. Okay, so they all have that same square as we go up that cross section, or up that shape. Okay, so all three of these have the same value. Another way to put it is, it doesn't matter if it's slanted. Okay, I think that's the easier way to kind of think about it. That's layman's terms. Right? It doesn't matter if it's slanted. That's what Cavalier's principle says. I can still just find the volume. Okay? So, but we need to make sure we're using the height. Okay, so for example, 1. Right, this is a slanted prism. The volume of a prism is volume equals length times width times height. My length is 4. You can see it has these little tick marks. That means they're congruent. So my width is also 4. And my height, you notice I don't pick this part. That's not the height. That's slanted. Since it's slanted, it's going to be longer. I want the height going straight down to the ground, which is 6. When I multiply these together, I believe we get 96 feet cubed. Our example 2 is a cylinder. Remember, the volume of a cylinder is pi r squared times height. Pi. My r here, this whole thing is 5, so just this part is half of that. That's 2.5 squared. And again, my height is going straight up and down. I'm not entirely sure what 2.5 squared is. Squared is 6.25, and then times 6, I believe. Right, 2.5 squared times 6, yes. And we get 37.5 pi, and this is in meters cubed. Okay, our last one is a cone. This is a slanted cone. Remember, the volume of a cone is 1/3 pi r squared times height. This whole thing is 36, so my radius is half that, 18. And again, my height I know its height, I know it's hitting that right because it's at a right angle. Okay? Just like these had those right angle symbols. So my height is 15. I'm going to again type this in my calculator. I get 1/3 times 18 squared times 15. And I get 1,620 pi centimeters cubed. That's weird. So all three of these, again, are just showing that it doesn't matter that it is slanted. All right, looking at example 4, a slightly different problem. So again, solve for x given the volume of the cylinder is 768 pi centimeters cubed. So this is a cylinder, so volume equals pi r squared times height. So I'm just plugging in what I know. Usually I'm finding the volume. That's not what I'm finding here. That means I should know what the volume is. And I do. The volume of the cylinder is 768 pi. I'm not going to worry about units while I'm doing my problem. Okay. Equals pi. Do I know what r is? No, it's just x squared. And then my height is 12. Okay. If I have several things on this side other than the variable, I want to make sure I simplify them. So I'm going to write, whoops. Hold on. There we go. I'm going to write this as 12 pi times x squared. I can do this because of the commutative property, right? 2 times 3 is 6. 3 times 2 is 6. It doesn't matter what order I multiply it. Now I'm just solving for x squared. I'm going to divide by 12 pi on both sides. I'm left with x squared equals, well, I have a pi and a pi. All I need to know is what's 768 divided by 12. I get 64. Then, taking the square root of both sides, x equals, the square root of 64 is 8. How you find the square root on a calculator is, we don't know, it's usually, even on the little calculators, it's right above where it says x squared. So you'll usually we hit control, or if you're using one of the little calculators, you hit second, right, and you can get your answer that way. So this is 8, and we should have a unit, 8 centimeters. Looking at example 5, solve for x given the volume of the square pyramid is 1,575 units cubed. So again, I'm going to start with my formula for a pyramid. Volume equals 1/3 length times width times height. I'm going to plug in all the things I know. 1,575 equals 1/3. I know my length. I know my width. Don't know my height. Again, I'm going to start by simplifying the side with my variable. I can actually multiply all of those things together. So 1/3 times 15 times 15. Is 75 x. Now again, last step. Divide by 75 equals 21. So this one I didn't have to to take the square root of anything because it was just x here. So once you plug everything in, you're really just solving an equation. All right, go ahead, turn to the next page. Here, there's no lovely picture for us. A conical cake takes up 32 pi inches cubed. The radius of the cake is 4 inches. What is the height of the cake? So it's a cake shaped like a cone. Draw a circle and draw a triangle. There's a lovely cone. Okay. My volume is 32 pi inches cubed, and the radius of the cake is 4 inches. So again, for a cone, volume equals 1/3 pi r squared times height. Just writing down my formula. I know my volume is 32 pi. My r is 4. I don't know my height. So I'll just keep it as h. That's my variable that I'm solving for. I'm going to simplify all of this. 32 pi. So 4 squared times 1/3, or 1/3 times 4 squared is 16/3. And don't forget your pi. When you have a fraction, the easiest way, instead of dividing, is just multiplying by the reciprocal, the flipped fraction. I'm going to multiply this side by 3/16. I'm going to multiply this side by 3/16. What happens? Well, if I'm multiplying 16/3 times 3/16, the 16s cancel out and the 3's cancel out. I'm left with pi times h. Over here, 3/16 times 32 is 6 pi. You could type that into your calculator. I'm not going to, just for the sake of time. Now I'm just going to divide by pi. So I'm left with 6, what is this, in inches, equals my height. So my cake is 6 inches tall. Alright, example 7 is going to be our last one, and the required notes. We'll do example 8 as an optional. So again, it's another cone. It has a volume of 81 pi inches cubed and a height of 9. So, volume equals 1/3 pi r squared times height. So need my volume. My volume is 81 pi equals 1/3 pi times, I don't know my radius, that's my variable. I do know my height. I'm going to multiply these together. One third times 9 is 3 pi. Divide by 3 pi. 81 divided by 3 is 27. My pi's cancel out. Here my 3 pi's cancel out. I'm left with r squared. We're going to take the square root of r squared. R squared is not a perfect square root. Right? If I look here, control square root of 27. That's not a nice number. Oops. I'm recording. So we like to break it up. What is a perfect square that goes into 27? I know 9 goes into 27, and it's 9 times 3. Then I just take the square root of these separately. I can take the square root of 9. The square root of 9 is 3. I cannot take the square root of 3. Okay? So this is just going back to reducing radicals. It's not the most important part of this, but it is a good thing to review as we will be using it in the next unit. My unit is inches again, and that is my radius, 3 square root 3 inches. That is it. I'll see you guys tomorrow, or go ahead and watch the extra problem.